Hello folks, how's it going? This is Mike coming back at you with yet another video on Precalculus. Today I have a short little video for you just to talk about some other properties of the trig functions and another way, sort of a subset of a way that we've already looked at them, but in one special and very particular case. So this is going to be a short video. Let's get right into it. From our previous video, we saw that the six trig functions are really based off of a point that lies on the terminal side of our given angle theta. And we can do that for any radius of any circle whatsoever. Well, really, the trig functions are based off of the unit circle, which is a circle with radius 1 and it's centered at the origin. So the equation for it is x squared plus y squared is equal to 1. Recalling the definition of a radian, in this particular circle, the radian measure of an angle is simply equal to the length of the intercepted arc, because s is equal to r times theta and r is equal to 1. So if t is a real number and we have an ordered pair x comma y, that is a point on the unit circle corresponding to this real number t, then we have the values of our six trig functions right here. Sine of t is just the y coordinate, cosecant of t is 1 over y, cosine of t is just the x coordinate, secant of t is 1 over x, and then tan of t is y over x, and cotangent of t is x over y. These are the exact same formulas as we saw from our previous video. The only difference is here r is a particular value, r is equal to 1. If you make the substitution of 1 for r in the formulas from the previous video, you'll get exactly these things right here. So this is nothing brand new. We just specify that the trig functions really are based off of this special circle, the circle of radius 1 centered at the origin. Continuing on to properties of these trig functions, starting it off with the domain and the range of sine and cosine. The sine and cosine functions have the same domain and the same range. You can take any real number and plug it into sine and cosine, and you're always going to get out a number between or equal to -1 and +1. So the domain of sine and cosine are all real numbers. The range of sine and cosine are all values between and or equal to -1 and +1. The tangent function, the domain of the tangent function is all real numbers except odd multiples of pi over 2. Tangent is sine over cosine. Any value that makes the bottom equal to 0 we can't have. And what values of theta make cosine of theta equal to 0? Well, that's all odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and then also minus pi over 2, minus 3 pi over 2, minus 5 pi over 2, things like that. And the range of the tangent function is all real numbers. In terms of functions being even or odd, there are only 2 of the 6 trig functions that are even, and those are cosine and secant. Those guys are even. So what we're saying here is that the cosine of minus t and the secant of minus t equal just the cosine of t and the secant of t. The other 4 functions are all odd: sine, cosecant, tangent, and cotangent. So if you have sine, cosecant, tangent, or cotangent of minus t, you can take that minus sign and pull it out front, and you have minus sine t or minus tan t or so on and so forth. All 6 trig functions truly are periodic, but we really focus on the main three of sine, cosine, and tangent. But what does it mean for a function to be periodic? A function f is periodic if there exists a positive number p such that for all t values in the domain of f, f of t plus p is equal to f of t. And this smallest number p for which f is periodic is called the period of f. Now that's a perhaps odd definition. Let me clarify it as such. If a function has period p, once you go through an interval of inputs and that interval has length p, then the sequence of outputs that you get begin to repeat. It goes through a pattern of outputs that you get. And how long it takes you to go through one cycle of that pattern, if you will, is your period p. So what are the periods for sine, cosine, and tangent? The sine and cosine functions each have period 2 pi. The tangent function has period pi, as well as the cotangent function. That is to say, sine of t plus 2 pi is equal to sine of t. Cosine of t plus 2 pi is equal to cosine of t. And then similarly, tan of t plus pi equals tan of t. And cotangent of t plus pi equals the cotangent of t. Since cosecant and sine are tied in with each other, as well as secant and cosine, cosecant and secant also have period 2 pi as well. I'll just state that for the record, not something that you're really heavily quizzed on. So that concludes this short video here on properties of trig functions that I just wanted to mention. In the next video, we're going to take a look at the graphs of these trig functions and see how these properties come into play when we take a look at their graphs. And we're going to learn about what are essentially the transformations we can do with these graphs and the special terms that we have for these various transformations. So guys, if you have any questions or comments, please be sure to reach out to me. Email, text, snail mail, postcard, paper airplane, packages dropping from the sky, whatever you have to do. Otherwise, until the next video, take it easy.